space big. We have a lot of room to move around in. How come it's not tiny? We have no consensus about these things.
What is space? We actually still don't really know.
It is one of the deepest mysteries in physics.
The stage. It's an absolutely vital part of the show, and yet most of us, we don't even give it a second thought. But Isaac Newton, he did. This is how the father of modern science pictured space, as an empty stage. To Newton, space was the framework for everything that happens in the cosmos, the arena within which the drama of the universe plays out. And Newton's stage was passive, absolute, eternal, and unchanging. The action couldn't affect the stage, and the stage couldn't affect the action. By picturing space in this way, Newton was able to describe the world as no one had ever done before. His unchanging stage allowed him to understand almost all motion we can see around us, yielding laws that can predict everything from the way apples fall from trees to the path the Earth takes around the sun. These laws worked so well that we still use them for the things we do today, from launching satellites to landing airplanes. And the laws all hinge on one radical idea: space is real. Even though you can't see it or smell it or touch it, space is enough of a real physical thing to provide a benchmark for certain kinds of motion, like a skater. Newton would say that when she spins, her arms splay out because she is spinning with respect to something, and that something is space itself.
Philosophers have been debating the nature of space for a very long time. What Newton does is change the terms of the debate. And with that, essentially modern science gets born.
Newton's stage was a huge hit. It enjoyed the limelight for over 200 years. But in the early decades of the 20th century, a new set of ideas emerged that shook Newton's stage to its very foundation. Ideas put forward by a young clerk working in a Swiss patent office. His name? Albert Einstein. And in the hands of Albert Einstein, this new picture of space would solve a deep mystery having to do with the most familiar force in the cosmos: gravity. Newton knew that gravity is a force that attracts objects to each other, and his laws predicted the strength of this force with fantastic precision. But how does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. And Newton's laws provided no explanation. After puzzling over this problem for more than 10 years, Einstein reached a startling conclusion. The secret to gravity lay in the nature of space-time. It was even more flexible than he had previously realized. It could stretch like an actual fabric. This was a truly radical break for Newton. Think of this table as space-time, and think of these balls as objects in space. Now, if space-time were nice and flat, like the surface of this table, objects would travel in straight lines. But if space is like a fabric that can stretch and bend, well, this may seem a little strange. But watch what happens if I put something heavy on the stretchy space-time fabric. Now, if I take my shot again, the ball travels along an indentation in the fabric that the heavier object creates. And this, Einstein realized, is how gravity actually works. It's the warping of space-time caused by the objects within it. In other words, gravity is the shape of space-time itself. The moon is kept in orbit not because it's pulled to the Earth by some mysterious force, but rather because it rolls along a curve in the space-time fabric that the Earth creates.
With Einstein, space became not only real, but flexible. So suddenly space had properties, suddenly space had curvature, suddenly space had a flexible kind of geometry, almost like a rubber sheet.
It opens up a whole new way of thinking about reality that describes the entire universe. Einstein becomes Einstein because of that observation.
Where Newton saw space as passive, Einstein saw it as dynamic. It's interwoven with time, and it dictates how things move. So, after Einstein, space can no longer be thought of as a static stage. It's an actor, and it plays a leading role in the cosmic drama.